give everyone a chance to actually agree to the terms. And then, John, the floor is yours.
Okay, morning, everybody. Let me just go into share here. Yeah, my name is Jonathan Burgess. I'm with the Allegheny County Conservation District and Penn's Corner Conservancy. Penn's Corner is the fiscal sponsor for the River Alert Information Network. We have been for, I think, about a decade now. So we have some affiliates here, some RAIN members actually on this call, so they can correct me if I step out of line. But I just want to give an overview of this because I think when we talk about source water protection, obviously, our water authorities, utilities are big players, and that's sort of the network that RAIN seeks to support, include, and uplift. So the mission for RAIN is to focus on source water protection in the Upper Ohio River Basin. So largely for us, this extends up the Monongahela and its tributaries into West Virginia, and the Allegheny in the Ohio and Pennsylvania. So across that network in the Upper Ohio, RAIN is essentially built a network of members to establish a monitoring system for water quality that can be of use to drinking water authorities so that they can both constantly measure, but also communicate with each other in a way that is efficient and is supported by technology. So the goals here are, again, public health, watershed protection, and environmental accountability. The network is really, I guess, three prongs. Largely it was designed as an alert, early warning detection system for water authorities. So there is a network of, monitoring systems at each of the RAIN member sites that taps into a central network and communicates with each other so that data can be shared in real time. And it can also set up alert systems so that if there's a shift in water quality metrics, the RAIN members can be alerted to that and take appropriate steps. But all of this data that we're collecting is also conglomerated, it's integrated with itself, and it is also presented to the public. So we want to share this information, not just internally to the members, but also in an outreach, outward-facing way. And so, there is a public-facing map and a website with blog, and that's definitely one of the key prongs, is sort of building lines of communication between other people interested in source water protection and, these RAIN members who, live and breathe water quality on a day-to-day basis. And so, the third part of that is trying to help communicate and, improve communication between the RAIN members themselves. So, so that to be like with webinars like this, it's important to communicate on emerging threats, best practices, technological advancements. And so the idea for RAIN is that it's a place for these people to gather and to communicate with each other. The first prong that I mentioned, the alert, alarm, early warning spill detection part, was first established in 2007. And there was some funding from both West Virginia and PA, as well as the EPA, to develop this network. And so it's, largely spread across these four rivers in the Upper Ohio. And we have, monitoring boxes and loggers that are out there collecting data in real time, usually, maybe every hour, and that data is uploaded. We're looking at things like pH, temperature, and conductivity. Those three are probably the three most widely common parameters across the network. Some people have additional parameters that they're measuring, but I would say among all the active sites in RAIN, those first three are the ones that are uniform across every site. So right now there's about 23 RAIN sites. I would say, I think 11 are currently online and feeding data real time. And so we're working to get other sites online. So I know DHHR in West Virginia is interested in updating some equipment, and we're looking to do more outreach in that state and hopefully get some more sites online in the coming year. This is just sort of a static image of the map, but you can actually go to the website rainmatters.org and see this in real time. And it just gives you sort of an image of what it looks like, and somewhat similar to Three Rivers Quest. We have tried to integrate other data sources so you can at least see our sites alongside some of the other monitoring networks in the region, like USGS sites. So you can add layers to the map, but you can also see all of the active and inactive sites and see the data, sort of a simplified look at the data from any site that's active within the RAIN network. So this is kind of what it looks like when you go to the map. Equipment, we may be looking to update some in the next year or so, but initially what we started with were these Hatch SC1000 source water panels. It was a good call at the time, and we were getting a lot of support with keeping them working and technical assistance. As time goes on, you will probably look to replace them with something a little more modern. And so I know that's something that the RAIN network is going to be actively working on in the coming months. But these source water panels, which are located at the RAIN member authority sites, so they're sort of adjacent or on the property of the water authorities, patch in using a Welbeck communication network into a server, and then it goes live to the site. So we have sort of this whole customized process for collecting data, transmitting it, processing it, and then putting it on the map. So it requires a couple of partners working in concert, but the end result is that we're able to see a lot of this data in real time. And I think that's obviously a great benefit to both members of the public, but largely to the RAIN members, so that they can see what's happening on other sites and they can see what's happening on their own. And so I mentioned that there's a public facing map, which anybody can go and look at, but there's also kind of a login members only side to this that has slightly different visuals, a little more detail on the data, for various reasons. The member authorities themselves need a little more detail and a little more, I would say, rapid response when it comes to data uploads and alerts. So the backend side for the members is something that allows them to set up alarm parameters. Water authorities tend to know what's normal in their area and what a variation, outside the mean looks like. And so the backend server allows RAIN members to set up customized notifications, alert systems, whether it's an email or some other type of alert, to set up how the reporting, their customized reporting looks. And then they can also update their contact information so that RAIN members can see who would be the proper person to reach out to at another site based on how they've set up, their profile, I guess, on the back end. Funding for anybody interested in water quality monitoring is always a challenge. It comes and goes, but we've been very fortunate to have some very supportive funders over the years. DEP in Pennsylvania was a big funder for a number of years when there were some source water protection funds that we were able to tap into to help build out the network. We've consistently and continue to get support from West Virginia DHHR. Gotta say thanks to Brian, since he's on the call, and Ruben Gillespie and all the folks there. So, the grants we receive from them allow us to keep doing network work and hopefully in the future update some of this equipment. And then since we're talking about PFAS after this, I just wanted to plug that the Pittsburgh Water and Sewer Authority gave us a grant this last year to do some PFAS outreach among the membership. So, we're probably going to be ramping that up, but there are a few articles and blogs from some of the drinking water authorities about PFAS on our website right now. So if you were to go to RAIN Matters, you could see some sort of general public blog information about PFAS. And then we have received funding from Peoples in the past as well. So I want to acknowledge that. This is what the website looks like. It's at rainmatters.org. It's a pretty looking website. Hopefully it's easy to navigate. We've been trying to make some improvements for better public access. So, encourage you to take a look. Obviously, if you have any comments or anything, my email will be at the end of the presentation. So, love to hear them, because we're kind of actively working on making this more user-friendly for the public. We also, in the past, pre-COVID, have done outreach as well in a physical way. So We've got flyers and things that we've used at public events and, conferences and things like that to try to educate people on source water protection. Because I work for a conservation district on my day-to-day job, we're active in watershed groups and, local municipal planning efforts. And so really trying to build that thread between RAIN and all the other folks out there, researchers, members of the public, local government, state regulatory officials, that are interested in, collaborating on source water protection efforts, because it really does take everyone to do an effective job at tracking and improving source water. So yeah, for RAIN, we're going to be probably doing an outreach push in the next year to try to get more folks in West Virginia involved, more drinking water authorities. Obviously looking to install and update a lot of the equipment. We've reactivated committees across the states. And so just really trying to encourage involvement among RAIN members. It's sort of a big network. Penn's Corner is largely comprised, our board of the conservation districts and the county officials across Southwest Pennsylvania. So we're trying to build networks here in Pennsylvania, build them in West Virginia, and then, so when we can, work with federal officials like the EPA on source water protection and water monitoring issues to sort of, bridge those political geographic divides that are really unrelated to watersheds and water quality protection. So we have a lot of partners, acknowledgement slide there. So we really do appreciate support. And, we just encourage anybody that's interested to reach out. We're actually looking to hire a contract position for RAIN in West Virginia right now. So we've got some funding from DHHR to visit each of these monitoring sites and, to assess them and see if they have any server issues and to kind of help do some outreach among RAIN members. So if you are interested or people who are interested in that type of work, it's a pretty good position. It runs through next summer, pays well, and it's part-time with travel compensation. So if you're interested in that type of work in West Virginia, with water quality monitoring, visiting authorities and utilities, please reach out to myself, or if Mike Anderson at MUB, you can reach out to him as well. We're just sort of posting that and shopping it around. So shameless plug for the open position. But yeah, that's it. So thank you very much for your time.
Perfect. Thank you so much, John, for that overview. I greatly appreciate it. And it was very informative. I did end up putting the website into the chat, so it will be easily findable from there. And then if you want to put your email in the chat, then of course people can reach out directly to you. Perfect. Well, up next, we have Melissa O'Neill, the Associate Director of the West Virginia Water Research Institute, to give a little preview into the presentation.
Yeah, thanks, John, for that background on RAIN. I think that you guys are doing great work, and I'm looking forward to seeing how we can partner more together in the future. So just kind of a brief background in terms of the West Virginia Water Research Institute. Its interest in PFAS, obviously, is an emerging contaminant of concern. It's something that we're very interested in. We secured a little bit of funding back in 2020 through our USGS 104B program to do some sample collection for PFAS in surface water throughout the Upper Ohio River Basin. But after realizing the complexity of PFAS sample collection and a little uncertainty on our part as to whether or not we would actually be successful doing grab sample collection, we reached out to EPA, USGS, Pennsylvania DEP, West Virginia DEP, and Orsenco to see what we could learn about the field collection methods and what was happening in terms of the analytical methods. Things have advanced very quickly over the past year in terms of where we were over a year ago. Analytical methods weren't yet published for commercial labs, and the field collection methods were a little intense, and we really wanted to make sure that if we were going to send people out to do grab sample collection, that we could have some confidence that we were following all of the proper procedures and that we would actually be successful in doing a surface water grab sample. So we ended up establishing these quarterly calls with folks from EPA, USGS, Pennsylvania DEP, West Virginia DEP, and Orsenco. And this has provided a really great resource for the different agencies and organizations to kind of share what they're doing in the world of PFAS and be able to share in terms of where things are in terms of developing the analytical methods, what they're learning about field collection methods, and so on and so forth. So as a result of this, we ended up partnering with Orsenco. They were doing or were planning at the time to do a Ohio River sweep, taking their boat out and using methods to collect for PFAS along the width of the rivers at various depths. And we provided funding for them to collect a sample on the Allegheny and the Mon, which would enhance their data set and provide us with some information on what's happening in the Allegheny and the Mon. So we're looking forward to seeing the results from those studies, and we'll hear more because we actually have a call, I think, tomorrow. Great relationships have been formed throughout these quarterly calls and being able to meet with each other on a routine basis and just kind of hear what's happening out there. So with that, one of the partners that I've gotten to know a lot better is Mitch McAdoo, and he's with USGS, and I'm going to hand it over to him so that he can tell you all what he's been working on in the world of PFAS.
Thanks, Melissa. All right, I'm going to share my screen here. You all have it? Good to go? Okay. All right, as Melissa said, we've been doing a lot of work on PFAS. We've been getting together a lot and talking about different methods and things like that. Some of the stuff we have going on right now, there's a lot going on in Virginia. I do some work over there. They have some contamination issues, plenty of military installations, things like that, where there's known contamination issues and they're impacting some of the public water systems. So we're actively involved with the Virginia DEQ and Department of Health over there and trying to answer some of their questions on public exposure to PFAS. But what I'm going to talk about today is this project that started somewhat back in 2019, and it's trying to understand permanent polyfluoroalkyl substances in West Virginia's public source water. And these are, when we say public source water, we mean raw water. This isn't finished water. This isn't a regulatory thing. This isn't for, understanding if, systems are over some sort of threshold or anything like that. This is before any treatment. So this whole presentation is going to be raw water. And it's important to understand that a lot of systems have treatment for PFAS, a lot of the systems that we sampled, and different types of filtration and things like that. So if I talk about anything as far as concentrations or anything, just keep that in mind. This isn't finished water, it's raw water. There we go. So I'm just going to talk a little bit about what PFAS are. They're a family of synthetic organic compounds. First developed by 3M in the 1940s, they're used in a whole bunch of stuff. Industry applications as surfactants and friction reduction applications. They're used in a ton of consumer products, like, obviously we know, nonstick cookware, Teflon, but they're also used in a lot of food packaging, water-resistant applications such as Gore-Tex, Scotchgard, things like that, and many others. They're ubiquitously used in consumer products all over the world. Another really important use of PFAS are in aqueous film forming foams. These are firefighting foams used by, in situations where you have petroleum fires and things like that. Especially used at airports and those applications. So PFAS are really persistent in the environment. They move with the water. They're very soluble, and they don't break down. So they call them forever chemicals. It's not exactly true. There are transformations and things like that that can happen to certain PFAS, but they last a really long time in the environment, and they're really hard to get rid of. Some PFAS have been shown to be bioaccumulative and toxic. And PFOA and PFOS are the most widely studied. I'll probably talk about them more than anything else, because there's a current ongoing regulation by the EPA. Right now we have a health advisory level of 70 nanograms per liter lifetime PFOS plus PFOA, so that's a combination of the two chemicals. And like I said, I'm going to talk about those more than anything. So this family tree of PFAS here, I got this from ITRC. They have really good references for PFAS if anybody's looking to try and understand PFAS a little more. The ITRC is a great resource. Anyway, so you kind of have this top member here, PFAS, which, you know, I've heard 3,000, 7,000, 10,000. There's a whole bunch of chemicals that could fall into the realm of what is a PFAS. So, taking it down a notch from there, we have polymers, and these are kind of end products like Teflon and FEP and some of these different products that are created from PFAS. And then we have non-polymers, and the non-polymers are what we're really measuring, and some of these non-polymers are what we're really measuring in aqueous solutions in raw water. So whenever you send a PFAS sample off and it comes back, the non-polymers are what you're going to be getting, and specifically perfluorinated non-polymers here, which means fully fluorinated. All of the carbon atoms are fully fluorinated on the molecule. We have the PFCAs, the carboxylic acids, and the PFSAs, the sulfonic acids. And in the carboxylic acids here, the CAs and the SAs, this is where PFOA and PFOS reside, right here in this perfluorinated branch of the tree. And you can see down here, I have PFOA and PFOS and kind of the molecular structure of what they look like. And you'll notice that whenever you're looking at a water quality report from a lab or something like that, they'll almost always report it as an acid, like perfluorooctane carboxylic acid. But down here, I have it as perfluorooctane carboxylate. They kind of mean the same thing. One is just the acid form. The carboxylate is actually the anionic form. So it's important for PFAS nomenclature to understand what you're actually looking at. They're pretty much the same thing. What you're actually measuring in the water is the anionic form, because as soon as these things hit water, they dissociate a hydrogen atom and become anionic molecules. And that's important. That's important for how these things behave in the environment. They create a negative charge, and they have the ability to desorb onto things and do different things in the environment based on that negative charge. The polyfluorinated part of the tree over here, these are things that poly means a lot. So not all of the sites on the carbon molecules are fluorinated. And these are what are called precursors in many cases. They have the ability to transform in the environment and eventually become perfluorinated through different types of transformation, pH changes, redox reactions, things like that. And the big ones that we're going to talk about in this presentation are the fluorotelmer sulfonates. There's fluorotelmer carboxylates, there's fluorotelmer alcohols, so on and so forth. I'm not going to get into every single type of PFAS here, but it's important to know that these polyfluorinated PFAS exist. They're used in a lot of different types of products, and they have the ability to transform in the environment, break down, and actually become perfluorinated. Now, polyfluorinated don't have any health advisories or regulations or anything associated with them, But it's really important to know and to measure these things because they can break down into things that do have regulations or health advisories associated with them, depending on which state you're in. And eventually, you know, these perfluorinated, especially PFOA and PFOS, will likely have an MCL associated with them from the EPA, but not currently. So, you know, that's kind of in a nutshell what PFAS are, and we're pretty much measuring in water these things down here, okay? Another thing about the molecular structure down here, you have a tail. This tail does not like water. You have a head. The head does like water. So it's amphiphilic. It has, you know, two different properties which make it an excellent surfactant. And that's really important because that's why they're used in a lot of industrial applications for that surfactant capability. They also have the carbon-fluorine bond, which make them extremely, it's one of the strongest bonds in organic chemistry. So they're extremely difficult to break down, which is a good thing for industrial applications at high temperatures and things like that. Just think of, you know, what we use Teflon for. A little bit about exposure pathways to humans. This figure, we created this figure, but it's actually after a publication by Sunderland. You'll see I have some references throughout this presentation. So PFAS sources and exposure pathways. So PFAS are synthetic, so they're made by different industries for different purposes. And those industries either make consumer products, they can make AFFF, which is firefighting foam. They sometimes release things directly into PFAS directly into the environment through emissions or you know, discharges or things like that. And they also have you know, direct routes to waste infrastructure such as water treatment plants and landfills. So, you know, all of these different pathways, you know, they kind of interconnect in here, but the main way to go from these PFAS created by industries to humans is through consumer products or releases into the environment that then contaminate things like water sources, crops, livestock, wildlife, and then are consumed. So, you know, the main exposure to humans are through ingestion and inhalation from consumer products or contaminated environmental sources. So why are we talking about PFAS and why is it important to study PFAS in West Virginia's public source water? Well, we have PFAS contamination sites that are already impacting public water systems in West Virginia that we already know about. There's several EPA actions and regulations that are going on that are going to affect our public water systems. We have previous sampling results that actually USGS did, we did, that showed us that PFAS exist in our environment. And we also have a need to protect public health. So for the PFAS contamination sites, we know that the DuPont Washington Works facility near Parkersburg, West Virginia has impacted public water systems there. And we knew going into this that the Air Guard base near Martinsburg, West Virginia has impacted water systems there. EPA actions and regulations. In 2006, the EPA set a combined PFOA plus PFOS lifetime health advisory level of 70 nanograms per liter. Now this is important. This is the initial step that at 70 nanograms per liter, that's what they set it at. That's kind of what everybody thinks is the you know, it's not an MCL, it's not a regulatory thing, but that's the health advisory right now. So that's the standard that everybody kind of looks at right now. So 70 nanograms per liter. EPA has several analytical methods. Melissa mentioned at the beginning of this, when we first started looking at these things a few years ago, back in 2019, there wasn't anything. There was essentially just guidance from DOD, the DOD QSM. And since then, EPA has come out with a couple of drinking water standards. They have a draft method for different media types like fish tissue, sediment, groundwater, surface water, EPA draft method 1633. So, you know, those methods are coming out and are being validated. And in 2019, the EPA issued a PFAS action plan to be in regulation process for MCLs. So that's why it's important to us. Those actions have, you know, consequences for our public water systems, and you know, we're going to have to, you know, understand what the larger implications of whatever MCLs they come out, how that's going to affect our systems. Previous sampling, USGS actually, we sampled 23 groundwater sites in the Ohio River alluvium in 2019. This was through the National Water Quality Assessment and also a project that we did through the DHHR with Brian on surface water influenced groundwater systems. And the results showed that we had several detections for PFAS in the Ohio River Valley. And now we were kind of expecting that. You know, we already knew that through the Department of Washington Works facility, we had contamination sites. But it also showed that PFAS is present in parts of the Ohio River Valley and demonstrated the need to, you know, investigate the rest of the state. Is this a prolific problem that we have everywhere? And the truth is, we didn't know before. We don't have the data. So in 2019, DEP, the West Virginia DEP and the West Virginia DHHR created the West Virginia PFAS work group, and USGS is also a part of that. And we meet quarterly and talk about PFAS problems and what we need to do, and the new things concerning PFAS. And in 2019, the West Virginia legislature actually passed Senate Concurrent Resolution 46, which directed the DEP and DHHR to do a statewide PFAS study. So ultimately, with all of those things, it culminated in the legislature passing SCR 46, you know, directing our state agencies to do this study. So why are we studying PFAS in West Virginia public source water? Eventually, the legislature directed the state agencies to do so, but there was a lot of, you know, build up to that with, you know, just knowing that there was going to be things that we had to understand whenever regulations came out. So Senate Concurrent Resolution 46 of 2019, it specifically says requesting the Department of Environmental Protection, Department of Health and Human Resources cooperatively propose and initiate a public source water study to sample PFAS for all community water systems in West Virginia, including schools and daycares that operate treatment systems. So this is everybody. It's not a, you know, we're going to pick 5 sites here, 5 sites there, where we think it's the whole state, sample everybody, including daycares and schools that are regulated and have their own water systems. And this is a whole page document. This is just one paragraph out of it. And there's really specific objectives that the legislature put forth too. And so the DEP and DHHR came to us asking us to help them with the project because we already had sampling methods in place and we had already been sampling on the Ohio River. So we agreed to help, and we work pretty closely with them anyway. So it was a natural kind of thing for us to do. So our project objectives are to meet the requirements of SCR 46, meet the requirements of what the legislature came out with, and that's specifically to identify drinking water sources with measurable amounts of PFAS. Determine, and these are drinking water sources, so this isn't finished water, it's the actual source water. Determine processes or land use factors affecting PFAS concentrations. Inform state agencies of any need for additional PFAS investigations, and assist state regulatory agencies in protecting public health by providing information on statewide PFAS distribution and source water. So our approach to do that is to sample all of the community public water systems in the state of West Virginia, and that's what that looks like. That's a map of where those actually are, and it's a pretty even distribution with some clumps in certain places in the east and the south and along the Ohio River, and you know, essentially do all that sampling with USGS personnel using standard sampling methods with, you know, a set number of crews that have been trained, so we can have a consistent data set across the state. Communicate with our cooperators and notify state regulatory agencies of exceedances. So we were constantly communicating with folks from the state as we were receiving results back from the labs. Publish USGS data release from proprietary public water system sites in a timely manner. So our normal way that we publish data is through the National Water Information System. But these are public water systems, so we can't release public water system location information. So the way we're releasing this data is through a USGS data release, and that also puts all of the data in one place. And essentially, it will be a reviewed spreadsheet where we have all of the information, and that data is actually in our database. It's just not available to the public because we can't release that location information, but we will release it as a USGS data release, just without specific location information. And that's planned to come out here in the next month or so. And then we plan to publish a peer-reviewed USGS report that summarizes the results and addresses the study objectives. So by next summer, we have planned to summarize the study and all of our results. These are the analytes. Don't worry about reading every single one of them, but just direct your attention to the little box here in the corner. We measured field parameters, pH, dissolved oxygen, conductivity, turbidity, water temperature, and we do that almost every time we go sampling to ensure that we're getting a representative sample and understand, also for understanding, equilibrium and things like that, just so we know that we're getting a representative sample whenever we go out in the field. We also, in addition to PFAS, we sampled for major inorganics, nutrients, and trace metals. So we have inorganic data for every public water system, surface water, and groundwater throughout the entire state. So just beyond PFAS, having that information from a geochemistry standpoint is really interesting to understand things like geochemical facies, different, in different areas of the state, and different minerals that may be affecting solute concentrations and things like that. So, beyond just PFAS, the data set that we collected is pretty extensive. Our timeline for this project for SCR 46, it started in July 1st, and we had planned to have it done by July 2022. So it's pretty fast turnaround for us. We sampled all of the sites in the first year, and we're working on the data, and we plan to publish the report at the end of the second year of the project. So our progress so far, and this is progress 2019 to 2021. So this is including NAQUA sites. We have sampled 279 sites across West Virginia for PFAS. So we have all of that, all of the sites across the entire state. That's what it looks like on the map. We did 50 QA samples, 36 blanks, and 14 replicates just for quality assure our data and make sure that we weren't contaminating things. And so that was a total of 329 total samples, QA and environmental samples, that we collected between 2019 and 2021. The majority of those were just collected over the past year between May of 2021 and July of 2020 to meet the requirements of SCR 46. So this included data collected from May 2019 to May 2021. And overall, trying to understand the public source water in the state, I think we did a pretty good job at getting a good distribution across the state. So this is kind of the overall, concentrations of. Remember that the PFOA plus PFOS health advisory level is 70 nanograms per liter. So that's what these concentrations are based off of. You can see large black dots are over 70 nanograms per liter, PFOA plus PFOS, and this is surface water, just the surface water sites in the state. We have 101 sites on this map, and then so on and so forth down to non-detect. So open circles are non-detects, essentially. And then we have a gradation of grayscale. And this scale is going to be consistent with all of the maps I'm going to show. And you can see we have some sites that have low-level detections between about 5 and 25 PFO plus PFOS, but nothing close to the 70 nanograms per liter health advisory level for surface water. For total PFAS, so if we take all of the PFAS analytes that we sampled, which is 28, and just add them all together, just to try and understand, get a composite number for each individual site. This isn't a regulatory thing, this isn't a health advisory thing, just kind of an idea of what PFAS are where in the state. Same scale, you can see that we've increased the number of dots that have detections. So there are other PFAS other than just PFO and PFOS that we're detecting. But still nothing, and I kept the same scale here, but this scale doesn't actually really mean anything, from a regulatory standpoint. Just did it for consistency. But you can see, we're relatively low, about 5 to 25 still, with a couple of sites that have higher levels of PFAS. One site specifically in the Ohio River. If we look at groundwater, and before I talk too much about the PFAS concentrations here, I'm going to go back to the surface water. You can see surface water is relatively evenly distributed. There's a lot of surface water sites in the middle of the state. If we go to groundwater, there's almost no groundwater sites in the middle of the state. This is highly dependent on geology. On the eastern side of the state, you have karst, where we have, a lot of groundwater systems tapping conduits and can produce a lot of water. On the western side of the state, you have the Ohio River alluvium, where we have a lot of groundwater systems in the Ohio River alluvium that can produce a lot of water for public water systems. In the southern portion of the state, there's a whole bunch of systems, especially in McDowell County. These are related to underground coal mines. These are discharges and wells that are directly into underground coal mines in a lot of these cases. We also have some karst systems in the valley and ridge over here that are coming out of springs and also tapping into conduits in limestones. In the middle of the state, we have fractured rock that just doesn't produce a whole lot of water in most cases. So that's why the big difference and kind of an interesting takeaway from this whole project has been that, where we have different types of public source water is highly dependent on geology, which shouldn't be surprising, but it's highly, apparent when we look at these maps. Now, turning our attention to PFAS concentrations, we have PFO plus PFOS, same as before. And you can see that we kind of have two areas of the state where we have high PFAS concentrations for PFO and PFOS, the Ohio River Valley and the Eastern Panhandle. If we look at southern West Virginia, almost all non-detects, actually all non-detects in underground coal mines, which is really interesting, and kind of shows that these underground coal mines in southern West Virginia are actually pretty reliable public source water supplies that can produce pretty good water too. Looking at total PFAS, we can see that there's a lot more dots in here, showing that, there's other types of PFAS that we're actually detecting. But, and there's some dots that show up in southern West Virginia with some PFAS in them, but really the main concentrations of different higher concentrations of PFAS are in the Ohio River Valley and the Eastern Panhandle. And, is that just because, there's different reasons why that might be, concentration of industry, concentration of populations, that's where the groundwater systems are. But these are kind of some of the things that we're going to be exploring as far as why those areas have higher concentrations. And it may just be simply those are where the point source contamination areas are. So it's looking at specific kind of summary statistics on individual PFAS detections for different analytes. You can see here PFOA plus PFOS, we had 37 sites that had either PFOA, PFOS, or both. And that was about 13% of our total sites. The minimum for PFOA plus PFOS was 4.4. We had a median of 7.6 and a maximum of 1,570. Now the 1,570, don't be alarmed, that was already known and treatment is already in place for that. So, you know, the big takeaway here is, you know, as far as looking at PFOA plus PFOS from the health advisory standpoint, is that, you know, the median is about 7.6, which is, you know, low compared to health advisory standards. And I don't know what the MCL is going to be when that comes out, but when it does come out, we'll already have data for all the public water systems. So we'll already be able to understand where we have problems or potentially have problems. Now, there were 12 individual analytes that were detected. We sampled for 28, we only found 12. There were 16 that we just never saw at any site, but these 12 came up, some of them came up several times, specifically 6,2-FTS. This is a fluorotellumer sulfonate. It's a precursor that's used in a whole bunch of applications. And it came in at 36 different sites, which is about 13% of our sites. PFOA was found at 29 sites, and which is about 10%, and so on and so forth. PFOA, which is one of the compounds for the PFOA plus PFOS health advisory level, was the highest detection we had. It was 1,570. And it wasn't just the highest detection that we had, it was the highest detection by orders of magnitude. There was only one other site that had anything close to that, and that was about 150. And then everything else was just much lower than that. So you know, the big takeaway from all of this is, you know, median values for all of these detections are relatively low. You know, they're not really ubiquitous. They're kind of concentrated in certain areas, but we have a very small subset of sites that have very high concentrations related to point source. And kind of a summary of all of that information. We had 279 sites that were sampled between 2019 and 2021. Detections for PFAS are generally concentrated in the Ohio River Valley and the Eastern Panhandle. Source water was generally dependent on geology, and higher PFAS concentrations were more common in groundwater than surface water. Only 12 of the 28 analytes were actually detected. Median values for detections were generally low, with a small subset of very high concentrations at specific sites. Out of 7,796 PFAS results, that's how many, you know, analytes we had, there were 164 detections. And when we take into consideration all of those analytes, all of these analyses, we had about a 2.1% PFAS detection rate, and those 16 analytes were not detected throughout the study. So our future project plans, we're not done with this yet. Our field work is complete. We plan to analyze the data, continue analyzing the data. We're going to publish the USGS data release relatively soon, and we plan on publishing an interpretive report around June of 2022. That's my email right there. If you have questions, feel free to email me. Something that comes up later. If you think about it, feel free to email me anytime. And these are some of the folks that actually did the majority of the sampling on these projects. I'd say between these three, that's me in the corner, but these three folks here, they probably sampled, I don't know, 70% of these sites. So they did a lot of field work and a lot of work at the height of the pandemic and getting out there and getting all this information. So they deserve a lot of credit. There's some really good technicians. That's all I got.
I'm
Perfect.
gonna jump in real quick, Mitch, and
Yeah,
say
go ahead,
thank you.
Melissa.
I've got to bounce to another meeting, so I hate to drop, but I've got a hard 10 o'clock. But thank you so much. I think that this was fantastic. And I'll have to look at the recording later to catch up on all of the questions and comments. But thank you so much, Mitch.
See you, Melissa.
And I'll just add, for anyone who might have to drop off at 10, I did check on the continuing education hours. The West Virginia DHHR approved those, and so I'll be sending them a list of all of the participants from the sessions. And so if anyone has any questions about that, just let me know. And if you're able to stay around, please feel free to ask some questions for Mitch.
Yeah, thank you so much for that. So if I could talk, thank you so much, Mitch, for that presentation. It was really informative. I wanted to kind of open up the floor to any of the other attendees to see if they have any questions or comments that they would like to share with either the group or ask you a question. I see Lance is unmuted. Lance, do you have something that you wanted to add?
No, actually, I have to leave for another meeting too. I
Okay.
just want to really thank Mitch and John for giving the a presentation. That's great.
Thanks, Lance. Yeah, the
Yeah.
presentations today were extremely beneficial. I gained a lot of information from both presentations. So I, for one, am stepping away with a lot more knowledge gained on PFAS.
See you,
Anybody
Lance.
else?
Hi.
Mitch, I just wanted to ask if there was any sampling that was done in finished water.
No.
Okay. I know
Not
that
by
for
us.
yeah.
Yeah.
All right. I just want to open up the floor one more time to any questions about Mitch's presentation for PFAS in general, any experience with maybe other studies surrounding PFAS. All right, I think the information was just so good that they just soaked it all up and there was no questions after that.
I'm sorry for being long-winded.
Oh, no worries. I was more concerned about the entire presentation concluding than the time because it was so valuable. So we really appreciate you sticking it out with us and giving us the in-depth version of this topic. So for anyone else that's still remaining, I just wanted to kind of see if you wanted to have any comments or questions about any of the previous sessions leading up to this session, just kind of conclude our series with any comments or questions you may have moving forward. Like I said, Mitch, I think you knocked them off your feet. So what I'll go ahead and do, thank you again so much. Thank you to all of our presenters for this series. We could not have done this without you. The information that you have provided was invaluable. And I have seen it in every single session that we were able to connect people from different regions, connect solutions together. And that's really why we want to continue these series, is to provide information and provide the connections so that we can go ahead and make real world solutions. So at this point, what I'm going to do is I'm just going to pass it along to Rachel, who's going to kind of give a concluding wrap up for the series, as well as provide a little bit of a preview for our next series starting in December.
Yes, so I am actually going to send a link in the chat here in a second. Just copy it. So this will be a quick survey. I think it's only 4 questions. We are interested in continuing this series, and so this is just to gauge interest in different topics. So I would really appreciate it if everyone could fill that out. I'll also be sending it in our follow-up email, so you don't have the time to click on that right now. So I appreciate that. And then secondly, I just really quickly wanted to go over a few planned seminars we have coming up through some of our other projects here at WRI. Let me share the screen. Okay, so we have 2 coming up, and One is on our Three Rivers Quest program, and one is more general to various research projects we have through the Water Research Institute. And both are monthly seminars online, and they'll be running from December through February. You can click on these links to register. I'll also be sending them out. And it's kind of similar to this seminar where there will be 3 different sessions on 3 different topics. And so you can pick and choose things that may be of interest to you. And so I just want to plug that very quickly before we finish up and thank everyone, including all of our presenters. I really enjoyed all 3 of the sessions. We've had a lot of really great conversations, and I hope you all can hopefully join us for some future seminars.
Perfect. Thank you, Rachel. I couldn't have said it better myself. So definitely be on the lookout for the email that Rachel will be sending with the recording, that survey to complete regarding future sessions, as well as the information to sign up for future sessions regarding a wide range of topics. So thank you again to all of our presenters, all of our attendees. You guys have made this series amazing, and we can't wait to start up the next series with you in December. I hope you all have a great rest of your Tuesday, and we will hopefully see you soon.
Thanks, everyone.
Take care, everyone.